Welcome to the Architecture Corner. We're here to peel back the layers on topics that, well, let's face it, generate a lot of buzz in tech.
Definitely.
Today, we're tackling low-code and no-code development. You've probably seen the headlines, maybe even that huge Gartner number.
Oh, yeah, the $13.8 billion projection for 2023. It's hard to miss. Makes it sound like the next revolution is already here.
Exactly. It's a sensational number. But our goal today isn't just to repeat the hype. We want to dig into what these tools really offer.
Right, because the true value isn't just adopting them wholesale. It's about figuring out when they make sense and where they actually fit. It's all about context.
That's the core message we got from a great piece by Mario Bittencourt, and it really frames this whole discussion. Perspective is key.
Absolutely. You open any tech site and boom, low-code this, no-code that. Those big numbers, like the Gartner one, they definitely grab your eyeballs.
They do. But does that huge valuation mean it's mature? Or are we maybe, still in the hype phase? What's hidden behind that number?
Well, it certainly shows a massive surge in interest and investment. No
Hmm.
doubt about that. But yeah, it also suggests we're likely right in the thick of that hype cycle.
Okay.
So before we get carried away, maybe we should nail down the terms, because low code and no code get thrown around together a lot.
Good point. They sound similar, but they're not the same beast at all, are they?
Not really.
Yeah.
And knowing the difference is honestly crucial if you want to cut through the noise.
All right, let's unpack it. Low code. What's the essence? Is it just about speed?
Speed is part of it. It's fundamentally a rapid application development approach, a RAD approach. Think of it like giving developers accelerators.
Accelerators, how?
Through automated code generation,
Mhm.
mostly. You usually get a visual interface, drag and drop building blocks. And this is key, it's designed for developers to jump in and add custom code when needed.
Ah, okay, so it's not just visual. There's an escape hatch, like Microsoft Power Apps.
Exactly like Power Apps. The whole point is shifting developer effort away from the repetitive stuff, the boilerplate code. Free them up for the harder, more innovative problems.
So it's finding a balance then between writing everything from scratch and, well, the other option?
Precisely. A pragmatic balance. Now, no code. That's also our RAD approach, also generates code in the background, but it's aimed somewhere else entirely.
Okay, who's the target for no code, if not developers?
Primarily business users,
Mm,
people who need to build applications quickly, but aren't expected to have, deep coding experience, maybe none at all.
right. So low code helps developers go faster and customize, while no code lets, say, the marketing team build their own campaign tracker without calling IT.
That's a perfect way to put it. And because of that target audience, no-code applications tend to be a bit more limited in scope. You're relying completely on the pre-built visual blocks provided.
No custom code option there.
Nope. It's all plug and play, totally visual. That's the fundamental difference. No code assumes no developer experience needed. Low code assumes and empowers developers.
Makes sense. And with all this buzz, it's no shock the big cloud players are jumping in, right? AWS, Google, Azure.
Yeah.
They all seem to have offerings.
Oh, absolutely. They're integrating these tools right into their ecosystems. Makes it easier to build on their platform naturally.
Which, sidebar, brings up questions about vendor lock-in, doesn't it? But maybe that's for another day.
It definitely does. That's always a trade-off to consider.
Yeah.
But focusing on the tools themselves, take AWS. They've got step functions.
Step functions. I've heard of that. Isn't that more for workflow orchestration?
It is, but it's highly visual. You define workflows by connecting different pieces, maybe some custom code and a Lambda function, maybe direct calls to other AWS services like DynamoDB for databases, or SQS for queues, EventBridge for events.
So instead of one big chunk of code handling the flow, you're visually wiring things together, like a flowchart that actually runs.
Exactly like that. He handles the state, the retries, the error handling between steps. Super powerful for distributed systems, implementing patterns like Saga, for example.
Okay, interesting. What else on AWS?
They also have Amplify Studio. This one's interesting because it ties into the design side. You can actually leverage Figma designs.
Figma, the design tool. How does that work?
Yeah, you can take designs from Figma, connect them to your back-end application logic. Amplify Studio provides built-in UI controls you can customize with point and click.
Does it generate code? Can developers tweak it?
Yes and yes. It generates code that you can modify before you deploy, and you can extend things using their cloud development kit, the CDK components. So it's definitely low code with that essential developer escape hatch.
Right. Okay, so that's AWS. What about Google? What's their play?
Google has AppSheet. This one sits firmly in the no-code camp, and it's very data-centric.
Data-centric. You mean you start with a data?
Pretty much.
Yeah.
You connect it to your data source first. And here's the cool part. It uses AI and machine learning to analyze that data and suggest initial settings for your app.
Whoa, AI suggests the UI, like based on my spreadsheet columns.
Sort of, yeah. It proposes things like which visual elements might work best.
Ah,
It's like having a smart assistant to get you started, which is great for those business users we talked about.
that does sound helpful. And then you customize it.
Then you use the point-and-click interface to tweak the look and feel, define how fields work, drop down lists, attachments, that kind of thing. Plus, you can build automation bots.
Bots, like automate tasks.
Yeah, based on data events. Like when a new row is added, send an email or call an external webhook, all visually configured.
Okay. And rounding out the big three, Microsoft. We
Yeah.
mentioned Power Apps earlier.
Right, Power Apps. It's a pretty broad platform, actually covering both no-code and low-code. They have two main ways in.
Two ways.
Yeah, you can start visually designing the interface first, like painting on a canvas. They call it Canvas apps, and then connect it to your data sources.
Okay, UI first. What's the other way?
The other way is more like AppSheet. You
Yeah.
start with an existing data source, connect Power Apps to it, and it automatically generates a UI based on that data model. That's the model-driven approach.
Got it. And extensibility. Can developers add code?
Yep. Similar to the AWS tools, you can extend Power Apps with custom code. Think Azure Functions for server-side logic or client-side JavaScript for the UI. Highly extensible.
You know, listening to all this, it feels like we've been here before, doesn't it? The software world loves its cycles. A new tool, a new methodology comes along.
Promising to be the definitive solution.
Yeah.
Oh, absolutely. It's a classic pattern.
The silver bullet surge.
Exactly. Gartner even mapped this out, right? Their hype cycle graph
Hmm.
shows how tech evolves from that initial trigger
Up to the peak of inflated expectations.
down into the trough of disillusionment. Always sounds so dramatic.
Aha, it does. Then hopefully climbing the slope of enlightenment.
And finally reaching the plateau of productivity.
Ah.
What makes it that far?
So the big question, where are low code and no code on that roller coaster right now? Are we peaking? Are we heading for the trough?
That's tough to say precisely. It probably varies depending on the specific tool and who's using it.
Yeah.
But the real takeaway, I think, isn't pinning it on the chart. It's about gaining perspective beyond the hype.
Okay.
It's about you, the listener, needing to decide very judiciously where these tools fit in your world and maybe where they don't.
Which is easier said than done when the promises sound so good. How do you make that call practically?
That's the million-dollar question, isn't it?
Ah,
Maybe a concrete example would help illustrate the trade-offs.
perfect. Let's take an e-commerce scenario. Say you need to figure out shipping for an order. Is it free? If not, calculate the cost. Then call the carrier, get a label, save it, maybe notify another system.
Okay, good one. Lots of moving parts. Some custom logic, talking to external services, saving data, sending notifications. Standard stuff, but complex enough.
Right, so option one. Let's call it pro code. How would that look?
In a pure pro-code world, you probably wouldn't use something like step functions for the main orchestration. You'd likely put most, if not all, of that core logic into a single compute unit.
Like one AWS Lambda function or maybe a containerized service.
Exactly. You'd still use cloud services, sure, but the brain of the operation, the step-by-step execution logic, lives inside your application code.
Okay, what are the upsides of keeping it all together like that? Seems familiar for developers.
It is. That's a big pro.
Yeah.
Familiar developer experience. You can use your existing testing tools, mock out those external carriers easily. The logic flow is right there in the code. You just read it top to bottom. Plus, maybe you can put off deciding exactly which database to use for storing that label until later.
Sounds pretty good, straightforward. But there's always a but, isn't there? What's the catch?
Well, the but is that your code has to handle everything. If that call to the shipping carrier fails, your code needs the retry logic, maybe exponential backoff, circuit breakers potentially,
All that resilient stuff falls on your shoulders.
Yep. and idempotency too,
Hmm.
making sure if the process accidentally runs twice, you don't charge the customer twice or generate two labels, that logic lives in your code. And maybe the biggest downside, just generally, more custom code usually means more places for bugs to hide, more code to write, test, and maintain over time.
Okay, that makes total sense. More code, more problems potentially. So let's flip it. Same shipping example, but now using a low-code approach like AWS Step Functions for the orchestration.
Right, so here you'd break that logic down. Instead of one big function, maybe you have several smaller Lambda functions, each doing one specific job. Calculate cost, call carrier, save label.
And Step Functions ties them together.
Exactly. The step function definition is the orchestrator. It calls Lambda A, then based on the result, maybe calls Lambda B or C. And importantly, you'd lean on direct service integrations,
Meaning,
meaning step functions might directly write the label details to DynamoDB itself without needing a Lambda function just for that database call,
mhm.
or it might directly send a message to an API gateway endpoint to notify another system.
So the step function workflow itself becomes the blueprint, the executable orchestration logic.
Precisely. It's a visual definition of your process flow. Now, pros and cons here.
Let's hear them. Pros first.
Big pro. Things like retries with exponential backoff,
Hmm.
often built in. You configure in step functions, you don't write code for it. Same for some aspects of idempotency.
Less boilerplate code for resilience. Nice.
Huge win. And generally, less custom code overall often translates to fewer bugs. Plus, and this is a big one for complex flows, you can visually track an execution. See exactly which step it's on, what the inputs and outputs were. Great for debugging.
That visual tracking does sound appealing. Debugging a flowchart beats log diving sometimes. Okay, downsides. There must be some trade-offs.
There are. First, the developer experience might be new. If your team hasn't used step functions, there's a learning curve. Second, testing gets different.
How so?
You still unit test your individual lambdas, but you also need ways to test the integrations and the overall step function workflow. It requires maybe new tools or approaches. The logic isn't all in one place anymore. It's split between the step function definition and the lambdas. And remember how pro code let you maybe defer the database choice. Here, because you're integrating directly in the workflow, you often make those choices like using DynamoDB up front. A bit less flexibility later, perhaps.
So comparing those two, it's really not clear-cut, is it? One isn't just flat out better.
Not at all. And that brings us back to the crucial point Mario Bittencourt makes in his article. Don't just count the pros and cons on a list.
Right.
What matters is your specific context. How important is developer familiarity versus built-in resilience for this project? How complex is the logic? What are your team's skills? Context is absolutely king.
That really sums it up. In this fast-moving tech world, we're always seeing the next big thing. Low code, no code, they definitely offer real value.
They do.
But the key is applying them thoughtfully, judiciously, based on your actual needs and circumstances, not just jumping on the bandwagon. It's about picking the right tool for the specific job.
Exactly. The real challenge these tools present isn't just learning how they work. It's forcing us to get really disciplined about understanding our own project's needs, our own context, before we choose any path, low code or otherwise.
That's a fantastic point. The technology pushes us to be better architects, really.
In a way, yes.
Mhm.
To constantly evaluate.
Which leads to a final thought for you, our listener. If context truly is king in deciding how we build software, how can we make sure our teams, our organizations, actually understand their own constantly shifting context in this world full of tech promises? Something to think about.
A really critical question for any tech leader today.
Well, this has been a great discussion. Thanks so much for shedding light on the nuances here.
My pleasure. Always good to talk through this stuff.
And thank you for tuning in. Don't forget to check the description for more information on today's topic. And hey, why not subscribe for free to the Architecture Corner newsletter? You can find it at architecturecorner.substack.com. We'll catch you on the next one.